We're continuing on with our forces, and this time we're looking at turning forces. Another name for turning forces is also a moment, and that is actually the position of where that force is acting on. So we'll have a look at these forces, and we use these all the time in opening doors, tightening nuts, using to pedal a bicycle or to put or apply brakes. Okay, so really, in these cases, the force has a particular effect, and it has a turning effect on a particular object. Okay, so you'll see these often referred to as a pivot. Another name for the pivot would be the fulcrum, and you would have looked at that in your technology, certainly key stage 3 anyway. So if you have a pivot and you have a long enough distance from the pivot, when you apply your force, you get this turning effect. Okay, and Archimedes once said that if you give him a long enough lever, he would be able to move the earth. Okay, and it's been used since ancient times. In Stone Age man, they would use something to lever a big rock or whatever. So we'll have a wee look at what we call this turning effect. And the turning effect is called the moment of force. And we can see them in various examples. As you know, in technology, you'd have different types of levers, depending on where the pivot is and what effect you would get from that turning of the fulcrum or pivot. So the most common one that we look at are seesaws. Okay, and here you have the lever, which is the bench that you'd sit on, and then you'd have the pivot, and that is where the turning force would be acting on. Other ones that we'd see are in scissors. So you would have the turning force here, which is your lever. You apply your force at the scissors. Okay, and it depends on that distance between the pivot and where you are acting the force. Another place where we would see turning forces would be a wheelbarrow. And again, it's another type of lever. So you would see the pivot in a different, I think you've described them as class A, B and C levers, and we would see a wheelbarrow, the pivot is in a different position, it's at the front, and your force is coming from the handle, and then you get the lever working on that. So a greater turning effect or moment. Okay, so just remember that we can call them a turning effect, a turning force, or a moment, and you get a greater turning effect when the force is larger. Okay, so if you put a lot of muscle into it, you can create a greater turning effect. Or the most important one, and this reduces the amount of force that needs to be put in, is the distance from the pivot is longer. Okay, we'd see that with basically the longer the lever, okay, or the distance from the pivot, the greater the turning force. So if you've ever tried, say for instance, to try and open up a tin of paint, you can open it up, say, with the 10p piece, but if you open it up with a screwdriver, you get a greater turning force. It's easier to open. Okay, so here is your pivot. Okay, so that's just really some examples where we would see a turning effect or a moment in action. And really what we're looking for is the equation of how we work that out. We see it in action in your technology, but we need to work out the mathematics behind it. So we'll have a look at that on the next page.